Given the graph f of x equals b to the x where b is greater than 1, draw the inverse and state the domain and range of both. What I should say is draw it and the inverse. Alright, so if we have b to the 0, we have 1. We have b to the first power. We don't know exactly what b is, but we'll just say, we'll call that b. If we have b to the second power, that's going to be b squared, something like this. And if we have b to the negative 1, that's the same as 1 over b. And if b is greater than 1, 1 over b will be less than 1. So our graph looks something like this. Our points there, and we can connect them. Now, what's the inverse? Remember, the inverse is a reflection about y equals x. Every point that was on the graph is going to be switched. So if we have, when we look at our graph, we had, looking at a table of values here, x, y equals b to the x. And so we had 1 over b, and 0 was 1, and 1 was b, and 2 was b squared. Well, now we're going to switch those, and so when we plug in b squared, we'll get 2. When we plug in b, we get 1, and we plug in 1, we get 0. And we plug in 1 over b, so some fraction, we'll get a negative number. So we don't know exactly where this is. I'm just going to throw it somewhere around here, and I'll call this thing b. And then over here we'll say is b squared. It's just really is to have this idea. So we have for f of x equals b to the x. Well, we can raise b to any power, so the domain will be all real numbers. Let's remember how to write this. X is an element of the set of real numbers. What's the range? When we look at this, what kind of numbers do we get out? We're getting out only positive numbers. There's no way to raise a positive b to any power and get 0. So y is greater than 0. Now what? What is the inverse? The inverse is going to be the exact opposite of those. And so the domain will be x such that x is greater than 0. And we can see that here. It's always on the positive side. And the range, though, will be all real numbers. And you can see that as well. This arrow is going up, 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 and this arrow is going down, down, down. What is this called? Do you remember what this is called? This is called a logarithm. And so that is actually our title. I wanted to go through this first. This is logarithms. So let's take a look at what we have here. This is called, if we say log of x equals a, right here, this log means log base 10, which is also called the common log. When there's no number written at the bottom of the g, it's not at the same level as the g at the bottom of the g, what that one is called is a common log. And it says log of x equals a if and only if 10 to the a equals x. Now, what is, when we look at this, what does if and only if mean? We could take a moment to refresh ourselves. If I say a if and only if b, this goes back to geometry. It means if a is true, then b is true. And it also means if B is true, then A is true. So it means you can go both ways. So if I have 10 to the A equals x, that's going to be this. I can transform that into log base 10 of x equals A. Now, what is a log? A log is an exponent. Let's write this. A log is an exponent. So when I have this thing and it says this log equals A, that's telling me the exponent is A. So the base of the log is also the base of the exponential. So the base to that exponent is going to equal the argument of the log. In general, don't quite have enough room here. In general, log base B of x equals A. And another way to write if and only if is a double arrow like this. Now, what's the base of this? We have a base B. B to log is an exponent. B to the A equals x. So this gives us a way to transform any log or exponential into the other one. Now there's a special base, and the special base is E. So what we get on there is log base E of x, and this is written, this is the same thing as writing natural log. That's what ln means. It's French, and it stands for, if I actually had a French accent, log naturel. So if we have this, we could say ln of x equals k if and only if what? Well, what's the base of the ln? We have to recognize as soon as we see ln, the base is e. So it's e, and log is an exponent. So k is our exponent. E to the k equals x. I threw k in there just so you could see something other than a. What do you know that is logarithmic? Well, one thing we should all know in California is the Richter scale. When we say there's an earthquake of magnitude 6 or earthquake of magnitude 7, they'll always hear that the magnitude 7 is 10 times stronger than a magnitude 6. Why? Because we're talking about an exponent, so we're talking about 10 to the 6th versus 10 to the 7th. What do you do in chem? Your pH scale. And another one that you could deal with is loudness of sound when you're talking about decibels. All right, let's do a bunch of problems. These are basically skill problems, and let's just see about how we can go about doing them. I see log of 10. What I'm going to do is set this equal to a variable, and I always want to see that you've done that. What's the base of this log? The base is 10 to the x equals this 10. Well, what is x here? X is 1. Let's see about this one. Again, we have a log base 10. It's not written. This is our common log, but it gives us 10 to the x equals 1,000, which I want to see that you're writing it as 10 cubed. I want to still work on the fact that we have two bases, two exponentials are the same with the same base, so therefore their exponents are equal. Now you could skip this first step, and that's okay. 10 to the x equals, how do we transform this one into 10 to a power? Well, we're going to go 1, 2, 3, 4, so it's 10 to the negative 4th, so x equals negative 4. Let's see a couple problems with different bases here. Set it equal to x. We have 5 to the x equals 0.2. Now, at first glance, this might seem, what do you do now? Well, if we take that same hint that in terms of the idea we did in problem 2, and we think of what Polya would say, can we put it into a similar form? These were easy because they had the same bases. Can we make this the same base? Well, 0.2 is the same as 1 over 5, which is the same as 5 to the negative 1. So x equals negative 1. We have two exponentials the same, equal with the same base. Over here, set it equal to x. 5 to the x equals 5 to the, remember the fourth root would be written as a 1/4 power, so x is 1/4. 5 to the x equals 1 this time, so what does x have to be there? This one will allow you just to look at it. X has to be 0. Remember, as long as the base is not 0, any number, non-zero number raised to the 0 power is 1. And we're going to start getting a little bit more complicated as we're going through this. We'll get 8 to the x equals 2. So now we have to look for a same base. We can have a base of 2 because 8 is 2 cubed. So 2 to the 3x equals 2. 3x equals 1. X equals 1/3. Set it equal to x. So we have ln. Actually, let me just start transforming it. We have e, the base of the natural log, to the exponent, x, equals 1 over e cubed. And that can be written as e to the negative 3. So x equals negative 3. And the next one, 7 to the x equals 1. It's just like the one that came above it. You just want to be thinking about that and make sure that you can deal with that.